class 8 students. Hope all of you are fine and safe. So we are again back with our online classes after a short summer break. Before the summer break, I have started a chapter, force and pressure, and I have discussed about the term force, about the rotational motion of a body as well as the translational motion and the moment of force, and also the unit of moment of force and how to calculate the moment of force. So let us recapitulate the same thing, okay, and we will come to the next point, pressure. So now the force, okay, when we define force, it is a physical cause which changes or tends to change the state of rest or motion of a body, which means that it is only a physical cause. Now why it is a physical cause means because to apply a force, we apply force externally from outside. Suppose if you want to close or open the door, okay, you use your hand. If you want to kick a ball, you use your feet, okay. Also to lift a bucket of water, again you will use your hand. So that means you use your body, either your hand or your leg, in order to do some work. That means to apply force, you will apply in order to apply the force, you will use your body. So that is why it is a physical cause, we call it. Okay. So this force will either make a body to bring in the state of motion, which are in the state of rest, a body which are in the state of rest, it brings in the state of motion. Or if a body is in the state of motion, by applying a force, you can bring that body in the state of rest. So therefore, this is the definition of the force. And the SI in the force is Newton. And also the translational motion. So to discuss about the translational motion, let us consider a body, a rigid body, but free to move. When a force is applied on that body, the body will move in a straight line in the direction of the applied force, which we call it as a translational motion. Example, a car. A car is rigid, very strong, but free to move. If you push the car will move. If you move the car, if you start the car will move. It is not fixed, okay, though it is rigid, but it is free to move. So when you apply the force on that car, the car will move in a straight line in the direction of the applied force, which we call it as a translational motion. So in a rotational motion, a body, you take a rigid body, but that body is not free to move. The body is pivoted. Okay, pivoted means it is fixed. So let us consider a body, okay, a body which is pivoted or fixed at a point M. Okay, so in order to, so this body is rigid, but they are not free to move. And why they are not free to move is because this body is fixed at a point. And let us consider a body is fixed at a point M. Now this body will produce a rotational motion. So how do they produce a rotational motion is when you apply the force on the body, okay, or when you move the body, now this body will move clockwise direction as well as anti-clockwise direction. So that means they will move in both the direction. So where will you apply the force? When you apply the force at a point M, the body will not move. Another example, you take a wooden scale or a plastic scale, okay, a long scale you take it, and you just fix that scale. In the middle you put a nail, okay, or some fulcrum, this is the fulcrum we call it, okay. With the help of the nail, you just fix a wooden scale. And when you try to move this wooden scale, when you apply the force at the point, at this middle point where you are fixed, the scale will not move. The scale will not at all, they don't move. So in order to move that scale, or in order to produce some rotational motion on the scale, you will apply the force in such a way that the force should be away from the pivoted end. That means this region is pivoted, okay, or this point is pivoted. So you will apply the force away from the pivoted region. Okay, you will apply the force on the pivoted. So that means you will apply the force at this point here. When we apply the force at this point here, what will happen? Now, when we apply the force, this portion will come down and this will move up. Then again, when we apply the force on this side, this will move up, this will come down. So what happens here is that now, when we apply the force, now you will apply the force at this region here, F. You will apply the force at this point F. Okay? And when we apply the force F, now you will move this downwards. When you move this downwards, this portion will come down and the another portion will go up. Okay? So that means clockwise direction it is moving. Again, what will happen? When you push, when you apply the force in this direction, that means in opposite direction now. Now this will go up, this end will go up and another end will come down. So therefore, they will move on both the direction, that means clockwise direction as well as anti-clockwise direction. So that means here what happens is that the body will not move in the direction they apply for, they will not move in a straight line, but the body will produce some rotational motion, which we call it as a rotational motion here. So therefore, the point where you apply the force is known as the point of action of force. So now this F is considered as the point of action of force. The point of action of force is the point where the force is applied, is known as the point of action of force. Now from here I draw imaginary line. That means from this point F, I draw a straight line here and I make it an X and Y. And this X and Y is an imaginary line. Imaginary means not real. Okay, it is a fictitious, not real. Okay, so XY is the imaginary line. So this line is known as the line of action of force. So what is line of action of force? Is an imaginary line drawn from the point of action of force. An imaginary line drawn from the point of action of force is called the line of action of force. And third one is there, that is moment arm. Moment arm is the perpendicular distance, this distance, the perpendicular distance from the axis of rotation. The axis of rotation means from this point the body will rotate. The perpendicular distance from the axis of rotation to the line of action of force is known as the moment arm. Okay, the third point is there. What is moment arm? The perpendicular distance from the axis of rotation, from this region, from the axis of rotation to the line of action of force is called the moment arm. So these are the three terms associated, related with the moment of force. And therefore, when we define moment of force can be written as M equals to F into D. Okay, M can also be replaced by another term. It looks like T, but this is tau, T-A-U, tau. So tau equals to F into D. So how you define moment of force is that moment of force is defined as the product of magnitude of the force and the perpendicular distance from the axis of rotation to the line of action of force. That means moment of force can be calculated as M equals to F into D. So this D is known as the moment arm. This D is the moment arm. So therefore, moment of force equals to force into moment arm. And moment arm is the distance. Now what distance is? It is the perpendicular distance from the axis of rotation. From the axis of rotation means this point, and okay, from the axis of rotation to the line of action of force. So this MF is the moment arm. So therefore, when we define moment of force is defined as the product of magnitude of the force to the magnitude of the force to the perpendicular distance from the axis of rotation to the line of action of force. So in the short form, moment of force equals to force into moment arm. Okay, so this is the definition of a moment of force. Okay. Now, moment of force can also be written as tau equals to F into D. Tau equals to F into D. F is the force, D is the distance. Now, what distance is that? That distance is the moment arm. Or we can say that this distance is the perpendicular distance from the axis of rotation to the line of action of force. So, now let us come to the next point is unit of moment of force. That means moment of force unit is there. So the SI unit of force is Newton, SI unit of distance is meter. So the SI unit of moment of force is Newton meter. SI unit of moment of force is Newton meter. Similarly, the CGS unit of force is time, and the CGS unit of distance is centimeter, and the CGS unit of moment of force is time centimeter, whereas the SI unit of moment of force is Newton meter. Now let us come to the some application of the moment of force. Now 3 applications we'll discuss it. Number 1 application is closing and opening the door. Second one is the handle of a grinder, the hand floor grinder is present near the rim. Third one is the handle of the spanner is long. Okay, so these 3 points we will discuss it. Now number 1 is the door. Okay, a door, it is easy to open or close a door when the handle is away from the hinge. So let us consider this is a door and this one is a hinge, H-I-N-G-E, hinge. Okay, and the handle is here near the edge of the door. So that is this handle is away from the hinge. If you place a handle at the middle here or very close to the hinge, okay, so that means this is A, B and C in the 3 places. Suppose if I keep in a place B and C. C is the reason, it is the place where it is very close to the hinge, and B is the reason where it is at the middle of the door. So when you place the handle at this region, okay, it is inconvenient, it will become inconvenient to open or close the door. Suppose if the handle is at B, okay, larger force is needed, okay, to open or close the door. That is the moment arm decreases because the distance between the hinge and the handle decreases. Okay, it becomes less. Then again, when the handle is at C, it will become unable to open or close the door because the moment arm decreases. So that is the moment arm is very less. You can see this reason here. Moment arm become very less on the 2 reason. So at the point B, it becomes inconvenient to let me see, larger force is needed in order to open or close the door. Whereas in C, it is impossible to close or open the door. You cannot do that. Even a large force is applied. But when you place the handle at A, okay, by applying a smaller force, you can close or open the door. Which means by applying a smaller force, it produces a large turning effect. By applying a smaller force, it produces large turning effect. So therefore, it becomes easy to close or open the door. So therefore, now why it happens is that when the handle is at A, the moment arm becomes more. That means the moment arm increases. So when the moment arm increases, lesser force is needed, or when the moment arm increases, the turning effect will be more, and even a small force will produce a large turning effect. So that is the first case. Second one is a hand floor grinder. Okay, so this is a grinder here. Okay, and this hand floor grinder, the handle of the hand floor grinder is present near the rim. So let us consider this is the rim. Okay, this is the rim, and very close near to the rim, the handle of the hand floor grinder is located. Now why it happens is that it becomes easy to grind the floor or a rice. Okay, in older days the people they use this kind of device in order to grind the floor or the rice. Okay, nowadays complicated machines has come here. So in villages also today also you will find it here, and the handle is located near the rim. So when the handle is located near the rim, the moment arm increases and it produces a large turning effect. The third one is the hand spanner. Okay, this is the spanner. This is the spanner here, and the handle of the spanner is very long. And this spanner are used to tight or loosen the knot. Okay, so these are used to tight or loose the nut. And the handle of the spanner is very long. Now why the handle of the spanner is very long? In order to increase the moment arm. Okay, the moment arm get increased because here in this region you will keep this region will be the screw, and you put the spanner on the screw. If that spanner comes in contact with the screw, and you just move either clockwise or anti-clockwise. When you move in the two direction, in one direction it will loosen the knot, and other direction it will tighten the knot. So therefore, when the handle of this spanner becomes long, the momentum increases, and therefore a small force will produce a large turning effect. So that means you have to apply very small force. Even a small force produces large turning effect, and therefore this spanner will make the screw to tight or to loosen. So these are the application of the moment of force. Thank you.